Hi everybody, my name is Tori Earle and I am an Extension Specialist for 4-H Youth Development with the University of Kentucky College of Agriculture, Food and Environment Cooperative Extension Service. Today I would like to present you one of the self-directed learning modules from the Kentucky 4-H Science, Engineering and Technology Core Project Area. These modules are designed for you to view and learn at your own pace. There will be text, video, review questions, as well as some interactive sections of the modules to aid in your learning and understanding of the subject matter. Please enjoy this and other modules related to the Kentucky 4-H Science, Engineering, and Technology Core Project Area. In the Activity Ocean Robot Test Tank, found on page 11 of the Facilitator Guide and page 9 of the Youth Guide, youth prepare their ocean robot for a research mission. Participants ballast their ocean robot by adding weights to create the sinking and floating behavior of a real ocean robot. Finally, they investigate data collected by ocean robots and learn more about the value of ocean exploration. By the end of this activity, youth should understand how ocean robots, gliders, work through exploration of density and buoyancy, and how to explore the data collected by ocean robots, and think about why it is important to understand climate change and its impact on ocean systems. In this three-part activity, the youth will engage by discussing and sharing what they think when they hear the word ocean, explore by looking at the logistics, importance, and engineering design that goes into conducting scientific research on an ocean glider, and make meaning by analyzing data collected from actual scientific research missions and answering questions based on their interpretation of that data. In Part 1, Mobilize the Mission, participants will take the map on page 9 of their youth guide and one of the 6 mission cards that they have. And they will determine the logistics that they need to follow in order to get their ocean glider to the location it needs to be. In that activity, they will have to name their science mission. They will have to determine which location they choose. And they will have to draw or write something that they learned or noticed about the geographic location that made them interested in it. Then they will have to think about how you're going to mobilize your mission, how are you going to get your ocean glider to that particular location, and they will choose one of the 6 locations on the map, which will correspond to one of the mission cards. From there, they will write out a plan and determine how they're going to make that happen. In Part 2, which is actually Ocean Robot Test Tank, your participants will construct an ocean glider to try to make it neutrally buoyant in water. The ocean glider itself comes inside your kit and it contains several parts. It contains 2 halves of the ocean robot itself. It contains fins to keep the ocean robot stable. It contains a gasket that will fit inside your ocean robot to try to keep it waterproof. And it also contains some connecting bands that, through experimentation, we've kind of determined don't necessarily hold it together really well. So what I'm suggesting is to find you some, these are size 32, number 32 rubber bands, and just get you a package of them and utilize them to hold your ocean robot together. We'll show you a quick construction of one of the ocean robots. Take the fins, place them on each side, and actually it might be better to put the gasket in first. You place it in what would be the bottom half of your ocean robot. press it down in the sides. Then you place your fins, large fins on the side, and then you can place the top half of your ocean robot on to make you a fully contained ocean robot. The tail fin goes in like this, and this is what your ocean robot is going to look like before you would get anything in it. But inside, you are going to have to add some weight or some ballast to it in order to make it just heavy enough to float below the surface of the water. On page 17 of your facilitator guide, it gives you an equation or some equations to try to figure out how to make that happen by making some calculations and doing some weighing. During the process, I found out that if you get you a small kitchen scale, now this is a digital kitchen scale, not promoting anybody, but I found it on Amazon. They are about $6 a piece, and depending on what you want to use for ballast, you can weigh what you have and determine what amount of weight or what amount of mass you need to put inside your glider itself. Some of the things that we have used in different parts of the experiment, we have used modeling clay, we have used pennies, we have used marbles, and we have even used BBs. That was a suggestion from one of my SET Leadership Board members. Give a shout out to Jordan McClone from Cumberland County. And the different things that you put in here, you will see that also there are different chambers, and you want your glider to kind of float tail up within a container of water. And I'm going to post a few pictures of that and how those were constructed and how they worked. So we'll post that, or you'll be able to see those here in well, right now. Some of the gliders that were created and how they worked. So creating your glider, or building your glider and making it neutrally buoyant, which means it floats just under the surface of the water, is the goal in part 2, Ocean Robot Test Tank. And this is the call, actually part 2 is called Driving School and Test Tank. So to do that, experiment, play with it a little bit, and see how well you can get your glider to float just under the surface of the water.